This video will present the algebraic proof of the Pythagoras theorem. I will use two different approaches to prove the Pythagoras theorem algebraically. The first one is here, where I have a c square and I have four right triangles, which is shaded yellow color. So I'm going to rearrange these 5 pieces, and these 5 pieces will look like this. In here I have a largest square, which is each side is a plus b, the two legs, the sum of the two legs, like a from here to here is a and plus b, and that is the largest square, which is a plus b square. And the blue square is the square constructed on the hypotenuse. So we have to find the area of the blue square. This is the first approach, and in the area of the blue square is going to be the area of the largest square, which is a plus b quantity square, and I will take away from that, I will take away the area of the four corners, like this. If I drag this, if I take away from the largest, if I take away the area like this one, so I will be left with the area of the c square. So this is what we are going to use this concept. Let me move it, slide it. If I cut and take away the four corners, I will be left with the area of the blue square, which is c square. So now algebraically I am going to discuss this using this method. Like in here, the area of the c square, the area of the blue square, which is this c square, and this area is going to be equal to, if I take the area of the largest square, which is a plus b quantity square in here, from this area, if I take away the four corners, each corner, the area of each corner is going to be half the length of base, which is a, times the height, which is b. So this is the area of each of the yellow triangle, which is the right triangle. So if I find the area, if I take away the area of the four corners from the area of the largest square, which is each side is a plus b, so the area of the c square is equal to the area of the largest square, take away the four corners, whose area is half ab. Now if I expand this a plus b quantity square, I get a square plus b square plus 2ab, and four corners area, if I simplify this, 2 goes into 4 twice, so I will have minus 2ab. So when I expand a plus b quantity square, I get a square plus b square plus 2ab, take away 2ab. So this is plus 2ab and minus 2ab, this cancels out, and finally we get the area of the c square is equal to the area of A square plus B square, which is exactly the Pythagorean theorem states. So now this is one way, and in this method I used the subtraction. I took the area of the largest square and I took away the area of the four corners. So that is the one approach. The other approach, I'm going to use it, and the other approach is going to be in the second approach I'm going to use, this is again the blue square, and I'm going to rearrange these four corners, but this time the four corners will be arranged inside the blue square. So like these four yellow triangles are being arranged inside the big square, which is C square. Now in here the area of the C square is equal to the area of the four yellow squares, like this one, four of these, plus the area of the blue square. I'm going to show you, like if I drag these four triangles, if I see that area, so the area of the blue square is actually the area of the four yellow triangles arranged inside the blue square plus the area of the little white square here. So now the area of the white square is going to be, because the length from this point to this point, this is B, and this length from this little piece from here to here is A. So you can see that this is B and this is A. So if I try to arrange them, so the yellow area or the white area is going to be the length B minus length A. So that will be this. So each side is going to be this from here to here. Let me use my pen to make color. Like this area, this is going to be, this little piece is going to be B minus A, and this little piece is, this side is also going to be B minus A. So the area, this one is going to be B minus A square. So the area of the C square in this arrangement is going to be the area of the, so I'm going to set them back. So this is the thing. So the total area of the C square in this case is going to be C square is equal to the four corners, 4 times half AB, plus the area of this piece, which is blue here, little blue, which is B minus A quantity square. Again, when I expand this B minus A square, which will be A square plus B square minus 2AB, and 4 of these corners area is going to be 2AB. So if I take away 2AB from 2AB, so this and this part cancel. Let me use the pen again. So this and this will cancel. If you take away 2AB from 2AB, so it will become 0. So the C square again is going to be A square plus B square. So this is another algebraic proof of the Pythagorean theorem. So these are the two different approaches I used to prove that the Pythagorean theorem. The visual approach you saw before, and this is algebraic proof. So let me summarize one more time. There are two different ways. First one, when I'm going to subtract from the I arrange these four triangles in outside of this, like one comes here and the other one will come here outside of the blue square, and the third one triangle will come here and the last one will go there. So that forms a larger square, which is a plus b quantity square. From a plus b square, if I take away the area of the four triangles, which is yellow, if I take away this, the four corners, then I will be left with the area of the c square. So that is what the algebraic proof I am showing here. And the other method is when I have to in this method I am going to take away, so it is a minus, subtract. And the other method, when I have to add these four corners plus the area of the square which is inside, and that is what this one is. So the area of this c square is equal to, in this arrangement, is equal to the area of the four corners or four yellow right triangle plus the area which is enclosed by these four sides, which is b minus a square. So using the same calculation here, four corners plus b minus a quantity square is going to be the total area, and that will give you the area of the c square. So this is another way of proving the algebraic proof of the Pythagorean theorem. I use two different approaches, one where the area is being added and the other one when the area is being subtracted. So this is the two different approach. I hope you understand the algebraic proof of the Pythagorean theorem and you will be able to apply them later.